Hello, today I am going to demonstrate Lenz's law to you. Here I have a copper tube. You can see it's a hollow copper tube, and then two similar pieces. However, one is aluminum, so this is aluminum, and this one is a strong magnet. It's called a neodymium magnet. The first thing that I'm going to do is that I'm going to drop this aluminum piece through the copper tubing. Now you will know that what's going to happen is that the aluminum piece will drop at the rate of gravitational acceleration, that is 9.8 meters per second square. But now let's look at what if I drop this magnet through this copper tube. Did you see? It takes some time for the magnet to drop. It's not like in the previous case. Why is this? So the magnet basically slows down when it falls through the copper tubing. You saw that there's no friction between the outer surface of this magnet and the inner surface of the copper tube. It's not due to friction. What happens is that we can explain this phenomena by Lenz's law. What's going to happen is that when I place this magnet inside the hollow copper tube, it's going to change the magnetic flux. The copper tubing, the conducting copper, is going to change the magnetic flux. Since the magnetic flux is changing, according to Faraday's law, there's going to be an induced EMF or an induced current that's going to appear in this copper tubing. These currents, they are current loops, and they are called eddy currents. So the direction, the orientation of these eddy currents is in such a direction that it will oppose the change in the magnetic flux. So this is what we call Lenz's law. So if the magnet is falling like this, let's assume that this is a north pole and this is a south pole. So then the eddy currents that are generated below the north pole will create a north pole over here. Like it will induce a magnetic field such that a north pole appears here. You know that north and north repulse. So as a result, there's an upward force acting on the magnet, and that will kind of break the motion of the magnet in the downward direction. Also, if we look at the top part, that's a south pole. So then, according to Lenz's law, the eddy currents will be created in such a way that over here there will be a north pole. So the north pole will attract the south pole, and then again there will be an upward force or a braking force. So when the magnet falls down, since its magnetic flux is changing, there's an induced electric current, which we call the eddy currents, that will create an induced magnetic field opposing the motion of the magnet. So that's why this magnet slows down when I drop it inside this hollow copper tube. Thank you. I hope you learned something very important about physics. So I'll be posting several more demonstrations like this for you to understand and appreciate physics concepts. Thank you very much.